Hello and welcome to another tutorial. We're going to continue our discussion on native image tool from GraalVM. So far we've looked at the default tool chain of different platforms because those are the prerequisites of compiling our Java application to a native binary using native image tool. And then we saw also how to install GraalVM, how to download it, install it, and then use the Graal updater to install native image tool on different platforms, macOS, Linux, and Windows. And now I'm going to just bring up a few notes from the official website of the native image tool. And there is also a very interesting website, medium.com, GraalVM, using GraalVM and native image on Windows. And it again walks you through the steps that I also mentioned. So if you want to learn more or details, then you can also always visit this online website. Some notes from the official native image website. This is from the GraalVM website. Prerequisites for using native image on Windows. So to start using native image on Windows, install Visual Studio and Microsoft Visual Compiler, right? MSVC. And I showed you how to do it. Now, the thing here is that the native image, especially on Windows, only works for the default toolchain of the Windows platform, which is MSVC. So you really don't have much option of using other open source compilers like GCC. At this point, I'm not really sure that it's even possible to use those, for example, GCC build toolchain with the native image on Windows. But for now, the easiest thing to do is MSVC. And when you run native image on Windows, which I will show you, it searches for CL or command line command, cl.exe, which is the MSVC compiler on terminal. And I showed you that you have to ensure that when you run the terminal and run the native image in the terminal, the path environment variable already sets up so that all the directories that are from MSVC are already on the path, so that the compiler has no problem finding, for example, the header files or other build tools required to compile a application, right? And I told you that it's best to define a few environment variables on Windows so that you can quickly set up the path and then call the native image from terminal. So there are two installation options for the native image on Windows. Install the Visual Studio build tools with the Windows 10 SDK, and this is what I showed you. Install Visual Studio with the Windows 10 SDK. So this is basically the full IDE, and that's what I downloaded. But you don't really need to also install the IDE. You can only use the build tools, and that's very similar to macOS, right? We said that Xcode, you can download the entire application. It's like 10 gigabytes. It's a very large application. It has a full featured IDE, but you don't really need that. On macOS, you just can install the command line tools, which are the build tools for the macOS. Same with Windows, you can also just download and install Visual Studio build tools, right? So you can use Visual Studio 2017 version 15.9 or later, and in my tutorial I use the Visual Studio Community Edition 2022, right? So I'm going to write down Community Edition, because that's the free edition, and obviously every platform must provide its own free build tools, otherwise nobody would be able to write applications. And so lastly, on Windows, the native image builder will only work when it is executed from the x64 native tool command prompt. And we saw that in order to do that, you want to go back and set up the path environment variable. You go to the MSVC, right? Microsoft Visual Studio Community VC, which is the visual compiler, auxiliary, and then the build directory. And there are different command line scripts that you can execute them in terminal, and then it correctly sets up the path environment variable for the build that you want to do. And we said that VC vars 64 is the one that we want to use on a 64-bit platform, and it correctly sets up the environment variables. And I also show you that it's best to actually define an environment variable that points to this file, and then whenever you type that environment variable and hit enter in terminal, it automatically executes this script and sets up the path environment variable. All right, so these are the notes on the native image. And again, your main option on Windows is to use the default toolchain, which is the MSVC. So native image only mainly searches for this compiler cl.exe. The command for initiating an x64 native tools command prompt is different if you only have the Visual Studio Build tools installed versus if you have the full VS Studio installed. Check this link for step-by-step instructions, and this link is basically pointing to this website, medium.com, GraalVM, using GraalVM and native image on Windows, right? So you can check this out. And again, it's I showed you all the steps. You have to go ahead and download the Visual Studio, and then you have to set up the path environment variable correctly by executing one of these scripts, and it automatically adds a lot of directories to the path so that the command cl.exe can work fine on your terminal. And after that, you can go ahead and create a HelloWorld application and then execute it to make sure that the native image works fine on your Windows platform. And that's what I'm going to show you next. So basically, so far we've set up the default tool chains of different platforms. We downloaded and installed the native image. We made sure that it works fine on all three platforms. And now we want to start learning about native image. What is it? So, or essentially, what is native image? As I mentioned before, it's a compiler. It's a tool that compiles your Java application to a native executable binary. That includes actually having a compiled version of the JVM, a very compact version of the JVM, garbage collector, all the pieces that the Java application requires to successfully run, right? But because everything gets compiled to a native binary using a static compilation instead of it running on JVM, right? With the operating system takes full control or full responsibility of running your application after the compilation, because there is no JVM, right? So GraalVM native image building tool, this tool can be used to generate an image that contains ahead of time compiled Java code. Now, ahead of time compilation is a fancy word for saying that we are statically compiling to the native executable binary, right? And again, to refresh your memory, Java compilation, or the job of the Java compiler, is to compile to an intermediate level binary. It's a binary that the CPU doesn't understand, the operating system doesn't understand, but the JVM understands that. So when you launch your Java application using JVM loads the class files, which are the binaries that the JVM understands. And then after JVM understands your class files, it tells the operating system what to do. So the JVM sits between you and the operating system, and the operating system sits between you and the hardware, right? There are some tasks that you want to ask the hardware to do in your Java application, and there are some other tasks that you're not concerned with the hardware, right? You just want to talk to the operating system. For example, terminal. If you want to print something to the terminal, you don't talk to the hardware, right? You don't care about the hard disk or the RAM or anything, right? And it's not an IO operation. It's just telling the terminal, hey, telling the operating system, hey, print this line to the terminal, right? So whenever you launch an application in your operating system, the operating system has to allocate some OS resources or operating system resources, right? And one of the resources is always terminal. So your application always has IO streams, right? Input streams, so that the user can give some feedback or the commands to your application. And again, the output stream is when the application can print something to the console, right? These are not directly related to the hardware. These are just some resources that the operating system has and it allocates to your application. And how do we use this native command? And again, when you open up a terminal, we said that you can either add the GraalVM bin directory to the path environment variable, so you can just type native image. But I didn't do that on my Mac OS because I want to make sure that when I type Java, it comes from my JDK 17 that I downloaded from Oracle, right? So if you append the bin directory of the GraalVM to the path, the Java comes from that because GraalVM also includes a JDK, which is an open JDK build. So I didn't want to do that. So I defined the Graal home and then bin and then native image, right? -- version, and we installed the latest version as of this day, which is 22.1.0, and it's built based on the open JDK 17. And as I mentioned, in the bin directory there is a Java or Java C. These are the OpenJDK versions, right? OpenJDK 17. But I want on my command line to have the Oracle JDK as my Java application, right? So just be careful which Java you use. I always recommend that whenever you want to execute Java C or Java, first check the version. So say Java C hyphen version, and it tells me Java 17, and Java hyphen version, it tells you which JDK it's using, right? Which JDK the terminal is finding on the path environment variable. So you say native image options, just like any other executable application. Any application, binary application, takes some options or command line arguments, and then the name of the class that has the main method, right? The class that is entry point to your application. And again, it's the class file, and then you don't include the .class extension. You just tell the name of the class. If it's inside the package, then you have to provide the fully qualified name. So this class is actually the fully qualified name. And then you want to tell native image what should be the name of the output binary. And we know that when we compile a C++ application, we can say -o, which means and then some name, right? And then the output is going to be named this name that you specify for the compiler. Same with native image. You can after you tell it which class file is the entry point to your application, then you can tell it first of all what's the name of the output is, and this name can actually be a full path or relative path to the output, which means you can say native image, right? And then my main class, right? And then you can say for example, put it in a directory called test relative to this current working directory, and then name it my_app, right? So what this does is that if this directory doesn't exist, then a native image actually creates this directory, and then it compiles your main class and puts it, and then the name of the application is going to be whatever you specify here, my_app in this case. And after the compilation, native image creates this directory and puts this the application with this name inside this directory, right? So if the directory doesn't exist, native image creates that. Now, one of the main options here for the native image, as I mentioned, is the class path, right? That's the most important parameter when you deal with any Java application. Same with native image. Native image, in order to compile the main class, obviously if your main class has some dependencies on other classes, other types, then native image should be able to find all those classes, right? Remember, native image is not a Java compiler. It's a compiler that takes all the class files necessary for running your Java application and builds a native image, a native executable binary. Now later we will see that you can actually also create libraries, like static or dynamic libraries that you can then for example use in other applications. So it's not necessary you don't have to just create an executable binary, but that's the most useful way of using native image, right? You write your Java application. Developing, compiling, and maintaining a Java application is much easier and much faster than developing a C++ application, especially in a huge project. Compiling a C++ application will take a long time, and the reason is that you might not be familiar with how C++ compilation works, but every CPP file has to include all the other files, right? Let's say if you write a CPP, just HelloWorld, and then include IO stream, the preprocessor copies all those code in the IO stream into your current CPP, and then the compiler compiles the entire thing, right? And then if you have a lot of these includes, then it takes very long time and resources, right? CPU resources to compile. Whereas in Java, we know that import statements have virtually no effect on your class files, right? Every class in Java gets compiled to a class file. Import statements are not basically written in the class files, right? They don't include any extra code. Instead, they get translated into the fully qualified name of your types, and then at runtime, the JVM has to be able to locate those fully qualified names. Same with native image, right? Again, import statements in your class files doesn't do anything, but then native image relies on the class path argument to find all the dependencies of your application, right? So not only you can compile a class that has the main method, you can also entire a jar file. You can compile a jar file using -jar arguments and then jar file. And you have to be careful that this jar file has to be executable, and in order to make a jar file executable, you have to have the manifest.mf inside of it, and then the manifest.mf has the information about which class is the main class, which class has the main method, or which class is the entry point to your Java application. And I will have examples in the future lectures on how to make a jar file or how to make a executable jar, and then how to compile it with a native image, right? All right, so what are these options? So we have two options here. One of them is in orange, one of them is green. For now, I'm going to look at a few. This is not all the options here, but a few of the orange options that you give to the native image when you're compiling your application. Obviously, you can tell that the most important one is the class path, which you can type it in three ways: -cp, -class path, -class, -path, right? So if you want to keep this hyphen, you have to use two double hyphens here so that the native image understands that. I mean, my favorite is -cp. It's very concise. And then the class path separator is a colon on any platforms. Windows, macOS, Linux, doesn't matter. Java always uses a colon for the class path separator. What this means is that you can have multiple directories on your class path, and you separate them with colon, right? So any of these can be used with a colon separated list of directories. Jar files, so you can even point to the jar files, because jars are like a compressed archive, and the JVM or the native image, they know how to unarchive this, decompress it, and access all the class files inside of it. So not only directories, jar files, or even zip archives, the compressed archives like zip, it also works fine. Native image knows how to access the class files inside that. Note that this zip archive shouldn't include Java source code, right? It should include class files or a compiled Java source code, right? Native image works with the class files just like the JVM works with the class files. And then -d name equal value, a set of system properties. We've already seen these, and these are the system properties that basically pass to the JVM, right? Again, when native image compiles your application, it actually has a compiled version of the JVM. It's a compact version. -j flag pass a flag directly to the JVM, so directly to the JVM running image generators. So these flags are like, we know that, for example, you can set how much memory is the initial memory, right? So -xx flags, or for example, -xx, a Boolean flag is like print GC, for example. This is something that you can see the details of the GC. So these are JVM flags, and I believe you can pass them with this argument. We will look at this later and see if this works or not. But for now, -x or -xx, these are usually the JVM flags that you use. -o is the optimization level. As I mentioned, the native image does a static compilation, and if you say -o0, it means no optimization. 1 means a basic optimization default, right? So usually in C++, you can also have these flags. For example, G++, and then the name of your CPP, and then -o, for example, 3. I believe the C++ compilers have 3 levels of optimization: 0, -o0, -o1, -o2, and -o3. And same here. Here you only have 2 choices: -o0, -o1, which is the default. So if you don't specify any optimization level, the native image already uses the most optimized version, right? -verbose enable verbose output. -version print product version and exit, and that's what we've been using, right? So if we say GraalVM, graal home bin, and then native image, and then for this orange option, I'm going to tell it -version. This prints the version and then exits the application. It doesn't continue. So GraalVM 22.1.0 Java 17 Community Edition, and then we exit the application, right? We go back to the terminal. All right, so a Hello World native image in Windows in macOS. We've already seen this many times, but now let's have a closer look. You create a Hello World.java compiler compile with any Java C compiler, which is version 17. Because we're using GraalVM 17, you have to use a compiler that is at least 17, I believe. I mean, it's best to have the exact match. So you can either use the Java C that comes with the GraalVM, or you can use the Java C that comes with the Oracle JDK 17. They are compatible. Run native image tool on the class file, and then you omit the .class, right? Just like when you launch a Java application using JVM. So don't use the .class extension. So here's a quick example. So public class hello world and public static void main string args system out.println hello world from native image. This is our Java source code, and then here in my terminal I use the Java C from GraalVM, Graal home bin Java C hello world.java. Note that I'm in the same directory that this Java source code is, so I don't need to specify -cp and give it the directories for the class path. And then Graal home bin Java C -- version, I'm using Java C 17. And after I compile to the class file, hello world.class, I just delete Graal home bin native image, hello world, and I'm omitting the .class extension. And the compilation goes through, and then it creates the hello world application. Note that I'm not specifying the name of the output file. And then by default, if you don't specify the name of the output application, output executable, it's going to use the name of your class, main class, the class that has main, but all the letters are lowercase. That's why you see that the output application is hello world. All the letters are lowercase. So let's, for example, head to Eclipse. We've already done this many times, and even our hello world application had more complexity. It had dependencies, but I'm going to create a new directory here. Let's say hello app, or just app, right? Let's close this, and here we're going to new instead of direct, so we're going to create a new directory or file. Let's call it hello world.java, and we're going to say public class. Again, this is for refreshing your memory and then showing you that now that we've installed the default toolchain, and then we've installed GraalVM and the native image is set up, how we go ahead and create a simple hello world application. So hello world, and then public static void main string args, and then let's do a sysout system.out.println hello world from Java in a native image, and then exclamation mark, right? So this is our Java application. We open up a terminal at here, so where our source code is exactly in our current working directory, and then I can say Graal home and then bin Java C and then hello world.java. I'm using the Java compiler from GraalVM. If I do a ls, you see that now I have the hello world.class, which also shows up here. And finally, now that the class file is ready, first of all, I can check that my Java application is correct by running it on a JVM, hello world, right? So you use the Java command line application and then pass it the class file that is your main class, has the main method. And now, as you can see, my application works fine. Let's see. Oh, okay. So the reason is that right now I had another hello world in my test directory, and this was part of my global environment variable class path. So that's why now this JVM is picking up the class path and executing that application. So in order to avoid this, I have to explicitly override this class path variable, and the way we do it, we explicitly provide the -cp here, which means only look into the current working directory. And now it's correctly picking up. Okay, we have a 1 here, so let's remove this. And then let's quickly compile our Java application again. All right, So if you've already set up your class path environment variable, you have to be careful. You can always override the class path environment variable by explicitly providing this -cp to the Java. You can even append that. So I can tell you the first look into the current directory, append, right, with the colon, that's our class path separator, and then provide class path in double quote, which means what this does, I believe, let's see if this works. Or okay, so we made a mistake. Yeah, so let's clean up. So -cp first, so the dot goes first, and then class path, and then double quote, right? So what this does, it still runs correctly, despite the fact that I have two HelloWorld classes that are on my class path. But when you give the current working directory as the first directory in the class path, Java tries to search a class called HelloWorld in the current directory first. If it cannot find it, then it goes into the directories that the class path specifies. Now, if I change the order, I tell it first search the class path environment variable and then use the search the current directory. You see now it uses or finds this HelloWorld class because that's the class that comes up in the first directories which are in the class path, right? So you can explicitly override the class path by just providing all the directories using -cp, or you can also append the class path to the directories that you're specifying, right? So we're going to compile the class file now with the native image. So Graal home being a native image, I'm going to tell it -cp this current working directory. The name of the class file is HelloWorld. And then I'm going to tell it the name of my application is going to be my app. So it's going to compile my Java application. The entry point is this class HelloWorld. It's not inside the package. If it were inside the package, we have to provide the fully qualified name of the class that has the main method, and then the output is going to my app. It's going to create this native binary and puts it in the current working directory. So let's go ahead and run this, generating my app, and that's executable. So it's telling us that it's creating a native executable. We're using version 17 of Java, CCC, Apple Clang compiler, and then garbage collector is going to be serial GC. So compiling methods, looks like everything works fine. Almost done. Creating image, now it's and it's finished. So everything went fine. And then product artifacts, it's my app, which is executable, and then build artifact. The build artifact is a text file that tells you what kind of file you generated executable and what's the path or the to this application, which is my app, right? So let's go ahead, and obviously we want to check that the compilation worked fine. So // which means from the current directory execute my app, and HelloWorld from Java in native image. So we successfully created a binary, native executable binary for our Java application, which was a simple HelloWorld. And the other thing that I'm going to point out here, we saw already the command line arguments, right? And those are passed. If your application requires some, you can pass them here. But we saw that also we can use the system, like get property, and then give it the name. And then this returns a string, right? A string val or value. And then I'm going to say that sysout name arrow and then plus value. So if this system property is not set, we're going to set get null. So what I'm going to do is let's run our application with the Java. Or first of all, we have to compile it. So let's compile with Java C and then HelloWorld Java. It works fine. And then now we can run it with Java, specifying that use this current directory, and then name becomes null. And then we know that after -cp, we can tell Java -d variables, name equals Bob. And now this system property is set. And what we can do now, also use the native image -cp here, and before specifying the main class, we're going to give it -d name equals Bob. So let's compile again. So let's see if this works or not. If this doesn't work, then after the native executable binary is generated, we can also pass these at the time that we run the application. But if this works, then by default, this parameter is going to pass to our native executable binary every time you run the application. So compiling the methods, and after that, it's going to generate creating the image. Let's see if this works. Everything seems to work fine. And then if I said .my_app, and now name is null, so that -d parameter did not work as expected. But then now we can pass it here, -d name equal Bob. And now this works, right? So, and we saw this before, that not only you can pass arguments to this string array, you can also pass or set the system properties using -d, and the native image differentiates between the parameters that you pass. For example, these two strings are passed to this string array, but this -d name equal Bob is passed to as the system property. So they are this argument is not passed to this string array. Just I want you to understand this very clearly, that there is a difference in that, right? So but then let's go back and see if we can actually put this -d name. So let's see if we can pass it to the options here, -d name equals Bob. Let's see if this works or not. So initializing, performing analysis. So almost done. And then inlining methods, compiling methods. And then finally creating the executable file or the image. So the compilation was okay. So let's see if we run my app, what do we get? Name still comes as null. So it looks like we can't really set the system property directly when we're compiling them, but as I mentioned, you can always pass them at the runtime when you run your application, right? So I hope you enjoyed this lecture. Obviously in the future lectures, we're going to go into more depth about all the details of native image. So please stay tuned, and I'll see you in the next one.